Swayam Prabha. Digital India. Educated India.
Dear students, we are in module 8 of the course Fire Safety in Buildings. Now, in my previous lectures, we have discussed on the principles and all the norms, regulations, methods, how to control fire, but in this particular module, we will be trying to discuss the application in hospitals in particular. So, what we are trying to do in this is planning for fire safety in special buildings, where we will in this particular module take up hospital and healthcare center. As you know that we are trying to give a plan appropriate, so that the safety of the inpatients and all other hospital bound people who are in the service should be taken care in case of a fire, and it is a little special kind of building. That is why we are taking up hospitals at the beginning, because the patients may not be in a position to move. So, hospitals or healthcare centers, the need for the evacuation is very different than that of any general residence, where people are self responsive and responsible and can take some action, or they are free enough to move out of a building. But such spaces where people are captive, particularly those who are inside the hospital or taken into the hospital, or the inpatients, are in a very vulnerable position. But however, no one thinks while they are in a hospital that they might encounter a case of a fire. But yes, the people who are in the administration have to keep that in mind, and appropriate measures are to be taken in to the building and also the system, so that no people remains unsafe and does not get into a trauma, but are relieved or taken care of in case of a fire. Same is the case when it is an assembly building. It is a panic, because assembly building can house 200 people, 300 people, and people are not at all oriented to that space. They come for some recreation purpose, enjoyment, some play, to see some cinema, or to enjoy an evening. So, it is not unlike that fire can happen in such places. So, those are the places which are to be known to us, and we have to appropriately plan or design, keeping in mind that fire can happen anytime into such kind of facilities. No less are the old heritage structures, where the then built buildings did not have any planning to mitigate or evacuate people from the fire, or to mitigate the fire when there is such a occurrence. So, we will try to see what appropriate planning measures as well as requirements are to be met to keep the buildings or such buildings safe from fire. So, before starting on the actions, we will try to see, though it is taken from a little old document, but we see mostly earlier it was cooking equipments which was the main cause of the hospital fires. So, you can see over 52% is cooking equipments, and others were from trash and debris, from lighting, electrical wiring, some for cloth washers, dryers, medical equipments, electronic equipments, and so on. Over time, these elements have increased in good amount, and a lot of cases of fire in hospitals have occurred over time, and let us try to see them first and what were the reasons. So, May 1929 there was a fire in the most of them are in context of western countries or maybe not India. We have one or two cases from India also. So, it was improper storage and lack of ventilation when 70,000 X-ray sheets were burnt. So, you see a fire can happen from X-ray sheets, which X-ray films which were there in the basement. So, you can see, and 125 people had expired because of the toxic fumes from the burnt films. You see the next case 1949, it was 74 fatalities, combustible furnishings which where the smoke and the fire spread through laundry chute. Chute means the vent. So, all these previous lectures were giving where things were explained, but now you see in real life this laundry chute was the place through which the combustible furnishings led to the fire and the smoke escaped through these. So, we did not stand a chance, but they could not stop the smoke which was pouring, and it led to 74 fatalities. Coming to another psychopathic building of Mercy Hospital, where the doors were locked and the conditions of the patients were such they could not be taken out, which led to 41 fatalities. It is just after the year next. So, it was 1949 and it was 1950. So, the learnings are to be taken in today's hospital design. May 2003, another 50 years later, it led to 0 fatalities. It was in Chile. So, you see here highly congested mechanical floor. So, where all the machines and equipments are housed, the fire started there, but the trained evacuation personnels and the known procedures helped them to rescue or take care of the people, and 334 firefighters took 5 hours to control the blaze. So, do you think the hospital which is supposed to house so many in-house or inpatients were moving around here and there? No. So, there is a management how the hospital fire to be controlled. So, it was 0 fatality, and all the extinguishers, wall mounted extinguishers and the firewalls saved the entire or could contain the fire in its location. Some more, 2005, you see in San Jose there was a fire in USA, 19 fatalities where patients were trapped in the ICU, that means the intensive care unit. No evacuation plan, had insufficient signage and lighting. So, we had discussed all these points. So, they were insufficient and there was no evacuation plan. I had shown you particular evacuation plans in shopping malls, in hotels, where people are not at all oriented to the building, they come once in a while. So, sufficient signages could have saved some. Next, you see the other hospital, that is the St. Jude Hospital, there are 3 fatalities. What led to the fire? The material, old wooden structure. So, one block was made of old wooden structure, and it has 3 buildings, of which one is the old one, and it had an asbestos shed. Nowadays, from the material list, the asbestos is no longer used for the toxicity. So, this asbestos shed led to the fire movement from roof to the continuous building. So, that led to 3 fatalities and the facility was all under control, the fire was under control. Now, you see another case at Guana where it was 0 fatality, which was also on a medical structure, though 66 years of medical records were lost. 37 patients and 4 babies, as you can see here, could be evacuated by the hospital staff. So, the hospital staff are the key persons to take care of the patients out, because they are the people who are on floor, who are awake, who are well. So, we see our 2011 Indian case study, which is AMRI hospital in Kolkata, which ended up with 91 fatalities in 2011 December. And it all started from the basement, where there were flammable medical consumables. That means, it may be the cellulosic fire, it may be cotton, it may be cloths, it may be paper, which were illegally stored over there. So, as I told you in one of my lectures, that the refuge areas in many buildings are places of dumping or storing materials, which should not be. So, maintenance, regular visits are very important to keep those areas clean of any flammable materials. Now, you see these flammable medical consumables somehow got into fire, and the entire smoke that was built up was carried through the ventilation chutes, the air conditioned routes, and the people were smoke choked. So, it took no rescue operation was done, because it was on the middle of the night when the attendants were not so alert, and it took around 90 minutes after the start of the fire when the fire service came. So, the whole thing was a failure to some extent, and the deaths were due to smoke inhalation. So, this is how vertically the fire moved through the duct to the different floors and led to such a big number of fatalities. Another 2013, both in 2013, one in Japan, one in Russia, which led to 38 and 10 fatalities, where most of the doors and windows were locked and barred. So, people could not go for some rescue operation. It was a psychiatric hospital in case of Russia, whereas it was a orthopedic hospital in case of Fukuoka of Japan. So, 17 patients were in hospital when the fire started at 2:20 am, that is at the middle of the night, and the fire doors of the second and the third floor were not closed. So, which led to the the smoke spread. You can see the rapid spread of the smoke, which led to the smoke choking and 10 fatalities. And the fire station, obviously they came, but because it was the middle of the night and already there was no barrier between the two floors, that is the compartmentation was not formed, the fire engulfed, the smoke engulfed 10 people. So, see, fire cases, the cases of fire do not happen every day, but the training of the people, the material in place, the gadgets on service, the firefighters for rescue, all together make the place fatality free, can make the place fatality free, can keep the damages lessened, and can bring the building to operation, because it is a hospital. Now, coming to the key point for a safety of a hospital, it is called defend in place. That means, a person who is a patient should be kept in place. You have to defend the fire staying in place. How can that be done? So, that means your building or your floor plan should have compartments and it should be 100% fire safe, and if only the fire compartment people, fire floor and only that compartment are to be unsafe and they are to be taken into account one at a time. So, admitted patient safety responsibility of the hospital administration. So, when a person is admitted, it is expected that he or she is immobile. So, avoiding moving the patient out of the building is the key concern, because when there is a case, when it is a spread in the media, the patient party will be coming, but the patient is still the responsibility of the hospital administration. So, you are not supposed to take out the patient out of the building. So, the first point is horizontal movement. Can I take my patient, because my patient may remain immobile, can I take my patient from one compartment to the next compartment, avoiding any vertical movement? So, my first objective is any horizontal shift. So, you are not asking them to go down and go out to the ground. I am trying from my zone of fire, say this is my fire zone, I will take out them to the next zone, which is a horizontal movement. So, I am not planning any vertical movement, even if there is a staircase or a lift here, I am not taking them out. Vertical movement to be avoided. Need trained staff to move patients. Now, patients may have various complications. They may be on salines, they may be on drips, they may be mobile, they may be immobile, they may be sleeping, they may have a orthopedic injury, they may have a operation. So, we need trained staff for movement of them and appropriate systems for them to be taken, like we have a stretcher, we can move them in a stretcher from one point to other. We may have movable beds, but yes, where will we take them? We will take them, we have to have space enough to take them. So, first is move them horizontally from one compartment, the affected compartment, to the next compartment, and wait for fire alarm, fire suppression systems, fire suppression systems to act, and fire resistive construction is a key. As an architect, you must have fire resistive construction. It is not an office plan, office design, or it is not a plywood partition wall creating a difference between two wards or between two spaces or two cabins. So, material becomes very important. So, what are the indicators? You see there is a color coding, immediate evacuation, immediate movement, that is emergency move. So, people who are on the affected area, they need this immediate movement, emergency movement, evacuate immediately or patients and staff may die, no time to prepare. So, you have to take them out immediately. Number 2, there may be a set of patients who are very nearby, rapid, evacuate as quick and safely as possible, limited time to prepare, maybe 1 or 2 hours, follow procedures. Number 3 may be gradual, say the fire is not getting under control. Rapid people will be mostly in the same floor. Immediate, they have to be evacuated out, evacuated from that compartment to the next compartment maybe. Then gradual, no immediate danger, sufficient time for systematic evacuation procedure. So, you have some hours of shifting. And the fourth one is prepare only. So, who is giving this directive? From the control, the people, that is the administration, are asked to immediately do the move, rapidly take up actions or gradually. So, it is a preparedness plan. So, the fourth is prepare only, do not move patients, but begin to prepare for evacuation. So, you are alert, you are given an alert. So, evacuation decisions in hospital, one of the fire alarm is triggered. What has to be done? Identify the level of threat. Who does? The person is, the staff is given who is looking into the affair. Whether evacuation is necessary. Instruction to staff for sequence of evacuation to be followed. Designated person responsible for notifying the entire facility for evacuation order. So, in hospital, defend in place is the principle, even though when it is a case of fire increasing, these are the steps to be followed. So, now priority rating for immediate evacuation of patients are patients in immediate danger, ambulatory patients because they can move, patients in general care unit requiring transport assistance, then patient in intensive care units, and then patients in the operating room. Now, you see this is the priority rating. So, what we are trying? We are trying to evacuate maximum people who are in immediate danger, then the people who can move, the patients who can move, then the patients who are in general care, they only need assistance or help, then the intensive care, and then the operating. So, you see these two levels are the last levels, and they are to be located or kept in a very safe or fire protected zone, because these areas need support systems which are controlled either by electricity power or are gases. So, they may be on oxygen support, they may be on some monitoring, health monitoring. So, these patients are to be in a very secluded location, safe location, which also needs electricity. Say when it is a operation going on and there is a fire. So, no alarm should be there till the operation is ending. So, no air conditioning should be stopped. So, nothing can be surviving, means nothing can be working without electricity. So, this also falls in the emergency service, like the fire evacuation itself, the emergency light should be on, otherwise my pumps won't work. For the wet risers, for the dry risers, for the hose, the pump is a mandate, and that has to be supported with the emergency supply power, and it should be in the control room with its designated color coding. So, all these are to be accessed by the fire personnel at the immediate entry. Some special needs that may be required for disability purposes. Some patients may need equipments, as I was telling, it may be some battery operated replacement if required, but also the medications of the patients can be carried, and also the patients may need some psychological help. Now, where will these people be taken to? We are not doing hospital management, but we are looking into the fire case when it is a case of fire. Where will these people be or these patients be taken to? First is horizontally they can move to the next compartment. If they are to evacuate the building, we have to look into where they can be taken in, because the responsibility remains with the hospital management. The cases of the places of concern: medical gas, potential fire and explosion can happen due to medical gas pipelines. Mechanical shocks, we have to prevent any mechanical shocks, that is jerk etc., to protect oxygen cylinders, that can even be the starting of a fire. Operation rooms and anesthesia rooms, there are various anesthesia chemicals which, like chloropropane, ethyl ether, divinyl ether, ethyl chloride, which are anesthetic agents which are considered as flammable. We have to be very careful of that, and we must have floors. As an architect, you are to know, we should likely to be present should have conductive floors to dissipate the possible static charges. So, we usually put vinyl floors in these areas. So, such anesthetic rooms, anesthetic areas, the operation rooms should be associated with, expected to be associated with oxygen lines or oxygen cylinder, should have conducive floors, conductive floors to dissipate all positive static charges, and it can be rubber, it can be PVC. Mechanical ventilation, we have talked about this for smoke evacuation. Mechanical ventilation arrangement is required for operation rooms to maintain the air change, to maintain the air quality or the sterility of the operation theatre. So, there should be always a positive pressure in such area, so that no contaminated air infiltrates into the space. So, a mechanical ventilation system is continuously working in a healthcare facility. So, these are to be in operation even if there is a case of fire. So, they are to be with emergency power support. Plastic containers may have replaced lot of glass containers to avoid breakage. Materials should be taken care and to be kept safe away from fire, chances of getting fire. Biomedical waste also, there are pollution control rules regarding safe disposal of hospital waste, because from there also fire can start. The incineration process are required from where fire can also start. So, regular instructional programs and fire drills are mandatory in such hospital environments, whereas as I told, as architects you have to be concerned about the pressures, the gas lines, the mechanical ventilation system, the flooring and the materials which we will, and the compartment formation which we have already discussed in my previous lectures, but we will reiterate them and also see some plans where they are actually inserted. Now, NBC also has certain minimum requirements for firefighting installations in hospital. You can always refer to the NBC, National Building Code for Design, which talks about the water requirement, both static and overhead. It also talks about the pump requirement, its capacity and the pressure requirement. Pressure requirement, usually it is 2 bar of pressure at the rooftop and 3.5 bars of pressure at the booster pump level. So, these are all worked out and given in the NBC. I have not crowded with those data. Sprinkler system, alarm in the alarm operation, these are to be included within the hospital services. Yard hydrants, that is, if any fire is happening in the periphery or the site area, So, yard hydrants should be there. From there, for external firefighting, the yard hydrant should be accessible. Location of sprinkler system in basement, that is again, as we saw from the case studies, there were 2-3 cases which were from the basement. The fire has started and it has moved up, the smoke or the fire. So, sprinkler system in the basement is very important. Now, if I miss out, I again tell that the inpatient department, below that it is desired that the inpatient block, the basement should not be, basement can be below the outpatient block or the other blocks, but below this the basement should not be. This is the inpatient department or the IPD. This may be the outpatient department, the pathology, the all other things, but inpatient department and OT area, we are not supposed to put basement here. If it is not possible, if it is possible, we are not to put, if basement is required. If it is to be provided, then there should not be any continuous staircase, a staircase should not continue, a staircase should not continue to the basement. If there is a staircase, it should have a fire door between the basement and the staircase. It is not desired, however, even if it is there, it should be having a fire door at the point, that means at the ground floor to the basement. So, no fire in any form from the basement, fire or smoke from the basement should be entertained. And as I told you, the inpatient department are there where 24 hours the patients are inside. So, it is better to avoid having a basement below it. If the opportunities are not there, if you have to put, you have to appropriately tighten it with fireproof material or ensure the fire safety. Now, exit facilities, floor areas over 280 meter square, facilities shall be provided to move patient in hospital beds. In building or sections occupied by bedridden patients where the floor area is over 280 meter square, facilities shall be provided to move patients in hospital beds. So, if it is a large distance, then you see at least 2 exits should be there. Minimum 2 meter clear width of corridor. Why? Because patients will be supported with some material or will be in hospital beds. So, it has to be always considered that in case of fire, this will become very vulnerable, and the key is to maintain 2 meter and from the corridor serving patient bedrooms in buildings shall be 2.4 meter. So, that 2 side movements can happen in 2 stretchers and the patients can be moved. So, also the doors should close automatically in case of fire. So, all doors should be having the system automatic closure system, and whenever there is a movement by a patient or some administrative staff or caregiver, the door should automatically spring back to the normal or the closed location. No combustible materials to be stored at any point of the building or the section to where there are expected to be inpatient occupants. Minimum quantities of flammable materials such as chloroform, ethyl alcohol, spirit, etc., shall be allowed to be stored and handled. So, bulk storage of these items should be in a maybe separate building, and they are to be following the safe practices, because these are the key places from where the cases have been seen. Also, there exceptions are there for door and window locking for mental hospitals. So, this is a very specific area, we are not getting into it. So, they are assisted and the door closing and window breakage, all these things can happen. So, there are appropriate norms for designing that. Our NABH also provides a list of do's and don'ts, or maybe prescribes the regulations for designing hospitals, where they also give account for fire a lot. NABH recommendations for compliance for organizations with fire safety. Here they are asking for NOC from state fire department, multidisciplinary safety committees are there, meetings every 3 months, because as you understand that the inmates, that means the administrative staffs, are to be regularly made aware of these protocols. So, there is a fire safety manual also, which is a written plan for the fire prevention of the particular building, and the fire safety manual has the following components, like the plan for prevention and control, system of fire prevention and control, maintenance of SOPs, maintenance of schedules, codes for announcement, responsibilities of different departments. So, constitution of firefighting and evacuation team, evacuation plan, electrical safety. So, see, NABH has given a full list for safety measures to be taken up at a regular interval for fire hazards as well as overall safety. So, this is the National Accreditation Board for Hospitals, and these are to be followed in case of hospital design. So, a multidisciplinary committee which is headed by a fire safety officer, maybe they must hold rounds of once in a area for non-clinical areas and twice in a year for clinical areas as a meeting or address to the people. Mock drills should be there, which are obviously a part of a protocol for any assembly building also, or not to mention most of the buildings, like say a hostel, a hotel, where there are lot of people staying, and the administration is the only part which is the common part, who should be aware of all the things. So, these kind of mock drills, this kind of fire address by the fire safety officer are important, whereas as architects we go back to the signages appropriately placed, because they should be getting it at their exit point in case of emergency. So, fire signages should have glowing characteristics. So, the materials should be glowing in dark, should be bilingual, not only one language, one may be in local language, one may be our national language. So, it should be such that people are aware without any help. Egress route should be free from any material. So, fire doors, they are to be appropriately rated, remaining open at all times, preferably accessed by the panic bar. So, no one should shut down any door at any point of time just for the sake of locking it. So, they should be automatically locked, but with the operation of the panic bar, which I have shown you in one of my modules, the operation of the panic bar, only by pressing one can exit a floor. The fire cabinets are open at all times. Stairwells used for evacuation are pressurized, as we have already discussed for smoke pressurization. In case of hospitals, it is a must. Lifts are not in use if it is not a fire lift or a fire tower. HVAC systems have appropriate fire dampers to stop movement of smoke from one compartment to the other, as I had shown you earlier, that you can provide fire dampers between two compartments and prevent the movement of smoke from one zone or one compartment to the next compartment. appropriate time and number of type and number of fire extinguishers, regular preventive maintenance schedule, 10% random sampling of fire extinguishers to be done, approachable peripheral round, that means outside the site, that so that the fire brigade can make an access. These are some of the mandates which are to be done on principle, of which the takeaway is the signage, takeaway is the doors with panic bars, takeaway is the open position. So, you may not put any locking arrangement on one side of the door, so that the doors do not get locked. So, the entire staff should be well aware of the movement plans. Preventive maintenance and testing must be done. Rubber mats, as I have told, all electrical panels should have rubber mats in its area, so that in case of immediate closure, the rubber, there should not be any leakage. The earthing systems should be tested, and oxygen rich zones should be well protected with fire equipments. The UPS and the equipment room of the computers also to be should be properly ventilated and have proper flooring. So, these were the key things which are mentioned in the NABH. Now, coming to the structural elements, we may have lot of spaces within the hospital which are open spaces. Hospitals shall make provision for sufficient open spaces in and around its building to facilitate the free movement of the patients in an emergency or for the fire vehicle to access. Now, other than this, these open spaces can be used as spaces for safe zones, because people have to assemble out, people means the patients has to be assembled out with some time of stay over there, with medical support, with pharmacy support. So, a kind of small temporary shed can be made in such open spaces. So, you see, other than the all around space for having the passageway and the clearance of more than 4.5 meter width and 5 meter height for the gate, the open spaces should be such planned that people can be taken out in case of extreme emergency and can be given shelter as an assembly point, and there should be also a similar discharge point. Turning radius, setbacks, width of main street, roads not to be terminated in dead ends are the key points which are to be maintained in case of the open spaces. Coming to the basements, the key points are highlighted. So, the basement and the IPD should be isolated. Open ramps are permitted, but from the outside of the building, not from the inside of the building. Each level and compartment must have separate smoke outlet ducts. Mechanical smoke extractors must be separately provided for the basement. The basement should be designed to permit 30 air changes per hour. Emergency power supply should be there at the basement, because it cannot operate if it is fully dark. Fire dampers must be provided so that no smoke can be travelled from the basement up, because basements are the places where various supporting activities like laundry, like kitchen store, like garbage, like loading unloading of various hospital equipments, maintenances, all kinds of things. Other than that, AHUs, electrical rooms, all are in the basement area. So, this basement should be treated as a 2-hour fire rated compartment with appropriate locking for the fire movement or smoke movement with dampers into the vents, because that is the unseen area through which smoke can pass. So, all vents should throw its throw the gases outside the building and ought to be extracted outside the building, and it should not be connected to the main building, that is the main hospital building. So, you can see one picture. So, you can see one is the basement, how the jet fan installation in the basement is done. You can see this is the jet fan which is installed in the basement. This is how it is done in this picture. You can see that it is a totally independent, the air is getting into the basement. This is the ground level. So, this is one basement and this is the ground level, this is a part basement, and what is happening from here, these are the air inlets and that is the from there, that is the air outlet. So, fire resistant duct rated for stability, integrity and insulation, fire resistant duct work rated for stability and integrity, not for insulation, which is in the basement, fire resistant compartment walls. So, these are all fire resistant compartment walls and fire resistant compartment floor. These are compartment walls, this is the these are compartment walls and this is the fire resistant compartment floor. So, what is done? Enclosed basement extractor with non-return dampers. So, these are all there, but they are fixed with dampers, so that no air, no contaminated air, smoke infiltrated air can return back to these zones, and the outlet is outside the building. Also, the horizontal exit, as I was talking about, the patients are to be transferred from one side of a partition to the other side, and essentially fire safety provisions for horizontal exits are to be followed. So, the compartment or the 2-hour fire resistant and self closing doors to that space leads to the fire rated compartment, and the horizontal movement from one compartment or the affected compartment to the next compartment is the key. Also, you see the refuge area to be provided. So, these are the points which we had already discussed, and for the vertical movement it is the staircases, which one is the protected staircase or the fire staircase. It can be an external staircase or it can be an internal staircase, but whatever be it, it should be having or supported with automatically closing doors. Though the protected staircase is the fire staircase, all other staircases also should be supported with automatic closing doors. So, the mandates for the corridors, passageways are also there, which, as I already mentioned, 2.4 meter is the minimum, is the corridor width for two-way movements, usually for the inpatient side. Corridor walls shall form a barrier to limit the transfer of smoke, toxic gases and heat. Transfer grills, regardless of whether protected or protected by dampers, shall not be used in corridor walls. Openings, if required in corridor walls for specific use, should be protected. Now, these are the major points taken from the national building codes. So, you can always go through these documents when you are into the actual design, but the key takeaways are underlined or discussed or are already discussed. You can see this can give you some impression. This is a corridor within a hospital. So, you can see there is sufficient space, 2.5 meter space, 2.4 meter or 2.5 meter space is there for the hospital. You can see the doors to all the wards or inpatients where they are automatically closing and of appropriate material with proper gasketing. You can see on the corridor there is a mounting of a water sprinkler. There is a ceiling rose for the sprinkler system for the and the fire extinguisher is on the wall. So, this is taken from a regular working hospital, so that you can make out. So, this is the basic standard. Various spaces annotated with appropriate signage. So, you can see all the spaces, there are signages on the wall which are not very clearly seen, but you can see here there is a signage. So, actually these are giving access to various services. So, these are all marked. Compartmentation, as I told, is already there, and we will try to stick to the defense in place, and we will try to take help of the compartmentation principle. Let us see, these are various fire stops we have discussed in the previous lecture. So, these are all to be integrated. Non-structural elements in the hospital, these are the static water tank, fire pump room, yard hydrant. So, these are all discussed in several lectures. So, we are not going into detail. The wet rising main, it may have a dry riser, it may be having a wet riser, it may have a hostile box, it may have a automatic sprinkler system, it may have, it may not have. You can see the NBC code numbers are also given 6.4.4, 6.4.5. So, you can always go to the NBC and refer to these pages but the key takeaway is we have to create the compartment and plan for emergency and emergency escapes and how to manage the inpatient in case of an emergency. So, let us come to the plan, that will be more helpful. So, it is adapted from a book source, though it is not taken exactly, it has been redrawn. So, you can see the red lines which is of our concern, 30-minute fire rated. You see this is a ICU, pediatric ICU, there is another ICU here. So, see that is a 60-minute fire rating is this major wall. You can see the black wall. You are taking the staircase, here it is a black wall. So, it is 60-minute fire rated, whereas the red walls are 30-minute fire rated. So, this is each of them are compartments for half an hour or 1 hour. So, this is how all the walls, internal walls are rated, not the external walls. External walls are automatically 2 hour fire rated, but the internal walls are fire rated as we can see in the picture. And you can see this is the ICUs, this is also the ICU, and you can see there is a staircase block, this where from the vertical movement can happen, it is 2 hour fire rated. This is also another staircase where it is 2 hour fire rated, and also there are lifts. You can see in the another hospital plan where there is the operation theatre and the central sterile store, sterile department, that is the CSSD, where you can see 60 minutes fire rated is creating this compartment. So, this is one side, this is one ICU, you can see there is an ICU, and this side is another side, these are the OTs, you can see OT1, OT2, OT3. So, these are the OT side and its support function, which is segregated from the rest of the hospital part, that is the ICU etc., which is associated to the OT, that is 2 hour that is 1 hour fire rated. Now, you see this is the hospital lift and staircase, which is within the OT block. So, this is only to take care of the OT people movement. So, this is supported with this kind of staircase, whereas this staircase should also be fire rated. Similarly, it is the first floor plan, this is the ground floor plan. So, this is in the ground floor plan how it looks, that is these are the ward areas, and you see the same wall, it has shifted a bit and it has come here. So, this room has got included into this space and the wall has shifted. So, this is how the fire rated walls are located and mentioned in the drawing. Special hazard concerns associated with hospital fire, as I already touched upon, is the oxygen, which is the oxygen rich areas are particularly the OTs, particularly the ICUs, where patients are usually put for some time to oxygen, they are supported with oxygen. So, these areas are to be not to be neglected, rather taken as a safe area design. You have to consider these spaces where oxygen supply is there, you have to think of segregating them or putting into a specific compartment. Movement of smoke fumes, this has been discussed. We can create dampers, we can put dampers so that no smokes or fumes can propagate from one area or the high risk area to the next area. Electrical equipments, we have to understand a hospital may have a lot of electrical equipments and radioactive areas which are high power consuming. It may have a blood bank, it may have equipments for pathological uses, for pathological tests, all require high demand of electrical supply. So, that is also another concerned area. As I have told, the electrical panel rooms, the electrical supplies, these particular rooms should be having anti-static flooring. Lighting, water supply, medical equipment should be protected from water. So, at the moment we learnt about at this time we learnt about the sprinkler system, which is highly water driven, but various medical equipments, even the patients, we cannot just start pouring water onto them, neither we can sprinkle water onto systems which are equipments. So, the mist we have discussed earlier, the mist, water mist can be used, which lessens the amount of water usage, but helps in the control of fire. So, we have to be very careful on what kind of firefighting system we are inbuilting within the building and in which zone. So, if I give you a representation, command and control structure, you can see hospital incidents, commander, liaison officer, safety officer, evacuation coordinator. Now, you see the top is very strong. Unless there is a evacuation need, the evacuation wardens or the people on floor, the leaders are not made aware of, but the alarm goes and the patient tracking, transporting them, medical wardens, the triage leader, the patient destination, the assembly point, all becomes active if there is a movement required. So, horizontal movement, as I told, defend in place, then the vertical movement, shelter in place, that is the staff may be instructed to make preparations, but no movement. Evacuation routes should be clear and specifically assigned to wardens, health and safety officers will control the whole thing. Level of evacuation may be complete or may be partial. Evacuation is considered as the last resort. So, potential unmitigated threat to patients' safety is of concern. The need for personnel is important. So, the number of staff and the number of inmates, all these are made or taken care by the hospital administration. Evacuation transport equipment should be there, assembly points or the holding areas should be planned, discharge site should be ready. So, if we see, these are the evacuation transport equipments, which are like the sked stretchers or the backboards. They can be taken from vertical down. You can see this is the vertical lift, this is the carry, this is the horizontal lift, this is a pull kind of stretcher, sked stretchers. So, these are the equipments which are to be in place, and the use of them should be known to the medical the wardens or the attendants. So, the assembly point again should be having, or the holding area should be having some pharmacy attached to it, and they are usually taken to the discharge if the family members come for the rescue operation, for the taking back of the people. Otherwise, they are relocated to, the fragile patients may be relocated to another hospital or to kept in the proximity of the assembly point, from which the release of or the discharge can be initiated. Also, when we are looking for the assembly point, we have to be careful on the wind direction, because the wind can carry the smoke outside, and the assembly point should be located considering the wind direction. Now, several nearby sites adjoining a hospital can also be kept available for the rescue operation or for the assembly or the holding area till the patient parties come and look for the discharge. If the hospital cannot be into operation at a within the same day, the discharges are released. So, what we understand through the entire presentation or through the lecture is that the whole system is a total overall management system, where the patients are finally taken out from the building if necessary, or within the, or taken in or taken back, and they are given care, and that is how the entire hospital and the entire management works in case of a hospital fire. So, here are the list of references, and thank you.